This conference will now be recorded.
Training one and all. This is Rajesh. In our subject Embedded System Design, we will see our Unit 4 RTOS based Embedded System Design. So we are going to study about operating systems, tasks, process, threads, multiprocess, multitasking, task scheduling. So and the Unit 4 is named as RTOS, Real-Time Operating System Based Embedded System Design. So as you know, your embedded system based design approaches are super loop based approach and embedded system based OS based approach where you can use operating system as a real time OS or general purpose OS. So we'll just define what is an embedded system. Embedded system is a unique microcontroller based real time reactive system consisting of hardware and software. The software portion consists of the control algorithm which tells how a system must behave, and this behavior of your entire embedded system is controlled by a operating system. All medium and large scale embedded systems will have RTOS. Your processor will behave as per the instructions written in the memory, control algorithm written in the memory, but entire process, hardware and software interaction, memory, peripherals, this is all controlled by your operating system. So first we'll see what are the objectives. Next, it is introduction, the basics of operating system, types of operating system, task, process, and threads, and multiprocessing, multitasking, and task scheduling. So our textbook is Introduction to Embedded System by Shibu KV. So what is our objective? Here we should know what is an embedded system, what is an operating system, and what is a task, what is a process, and what is a thread. And from the task, we are going for multitasking. From the process, we are going for multiprocessing. And there is something called task scheduling. So we are going to learn all these concepts. See, this OS is required for medium and large scale embedded systems such as flight control system, industrial automation, missile launching system, where this operating system is going to do how how a system will behave, all task scheduling priority. So because an embedded system will is controlled by a processor, this processor is simultaneously reading multiple tasks, and after execution of one task it has to go to the next task. If in between any interrupt is occurring, this task must be uh, stopped and it has to respond to another task, and again the previous task must be invoked. So this all control part is done by your operating system. So as you know, these embedded systems are available in our day-to-day life. So we are at this stage we are define only embedded system. It is an electromechanical system and a combination of hardware and software, and these are some examples as we have seen in our previous slides. These are all examples, and our subject RTOS, real-time OS, is required in this metro rails, this medical applications, this car flight systems, navigation systems, satellite systems. So we'll see what is an operating system. The operating system is nothing but a code. Okay, it is also a code that is unique to your system. It's like the brain of your computer. For a Here the operating system is acting as the brain of your embedded system, and it is going to control hardware and software, application software. So it is acting as a bridge between the user applications or the tasks. The user requires some applications and tasks, and there are some resources. What are the resources? A sensor, a actuator, a printer, webcam, anything. So these all resources must be assigned to the tasks. A task requires input from a keyboard. A task requires output to a motor. So this all is controlled. The operating system is acting as a bridge between the user application tasks and the underlying system resources through a set of system functionalities and services. So by using the set of system functionalities and services, this operating system is bridging between the user and the resources. So OS manages the resources and sees that all the resources are available to the system as per the requirement on a need basis. And the main purpose of the OS is to make the system convenient to use and see that all the resources are efficiently used and correctly used. So if you see from the software side, there is an operating system above which there is an application program, that is the control algorithm or user interface program, above which we have a web browser, email reader and music player. So through a web browser or email reader or music player, we are interacting with our application program, and this application program requires some resources, hardware resources. Those are provided by the operating system. So operating system will be in kernel mode, whereas your user mode and all the resources of web browser, they will be in the user mode. So they software is totally software. OS and application software are software. Hardware is hardware. But your specially operating system will be in kernel mode, whereas user interface of program and web browser, email reader, music players, they are in the user mode. So another way of representation is these are all user applications. They are interfaced to your OS through a API. API stands for application programming interface. So user applications are interacting with your OS through API, and this OS is interacting with your underlying hardware using a device driver. So if you remember, when any system, if you insert a device, external device like USB device, printer, mouse, it tells you have to install corresponding device drivers. What is a device driver? Device driver tells how your device, whether it is an input device or output device, how much pin data it can take, whether it can take data serially or parallelly. So entire specification of the devices will be in the device driver. Once you attach your hardware to your system, the OS is going to identify, and it has to identify the logic of your device by understanding by studying the device drivers. So through device drivers, it is going to interface. And what is internal to the OS is there are a set of services. Those services are called kernel services, such as memory management, process management. See, a kernel is like the heart of your OS. It is going to see the memory management, how memory is managed, how process management, time is managed, file system management, input output system management. So these all five services are met by the kernel: memory management, process management, time management, file system management, and input output system management. So for an operating system, the core element is kernel. It is responsible for managing the system resources and communication among the hardware and other system services. Kernel acts as an abstraction layer between system resources and user applications. Kernel contains a set of libraries and services. For a general purpose OS, the kernel contains different services like process management, primary memory management, file system management, input output system management, secondary storage management, protection, time management, and interrupt handling. So for a general purpose OS, the kernel contains different services like process management, primary memory management, file system management, input output system management or device management, secondary storage management, protection, time management, interrupt handling. So this kernel is a small portion of code which does various services such as process management, primary memory management, file system management, input output system management, secondary storage management, protection, time management, and interrupt handling. So kernel space and user space. What is this kernel space means? A small portion of memory is utilized for OS, a small portion of memory is used for application software. So if the program code corresponding to the kernel applications are kept in a continuous memory along with your user space, and is see, actually the kernel space is the operating system must not be damaged. The operating system is the total control of your system. So this operating system consists of a kernel. So this kernel is allocated some space and it must be protected from unauthorized access by the users. The memory space at which kernel code is located is known as kernel space. All user applications are loaded with a specific area of primary memory, and it is called user space. And the partitioning of the memory into kernel space and user space is purely operating system dependent. An operating system with virtual memory support loads the user applications into corresponding virtual memory space with the demand paging technique. Most of the operating systems keep the kernel applications code into the main memory, and it is not swapped out into the secondary memory. So user applications can be kept in the secondary memory, but whereas kernel applications is kept in the main memory. So monolithic kernel, all kernel services will run in a kernel space. All kernel modules run with the same memory space under a single thread. The tight internal integration of kernel modules in monolithic kernel architecture allows effective utilization of the features of the system. The drawback is any error failure in kernel modules will lead to crashing of entire kernel, like Linux, Solaris, and MS-DOS kernels are examples of monolithic kernel. Monolithic kernel with all operating system services running in kernel space. So these are the applications, and there is a monolithic kernel with all operating system services running in kernel space. And there is a micro kernel. The kernel design incorporates only the essential set of OS into the kernel, and rest of the operating system services are implemented in servers which run in a user space. The kernel design is uh, highly modular, provides OS neutral abstraction, memory management process. Servers. These servers are kept for kernel services running in user space. Instead of writing your total kernel in one space, major portion, required portion is incorporated in a kernel space. Remaining portion is kept in user space, that is called servers. And this micro kernels with does the services like memory management, process management, time system, etc. QNX and Minix X kernels are examples of microkernel. What is the benefits of this microkernel is robustness and configurability. What is robustness is if any program is encountered in any services in a server can be reconfigured and restarted without the need for restarting entire OS. So configurability means any services which run as a server application can be changed without need to restart the whole system. So as of now, we have understood that there is a operating system which is controlling the hardware and software part, and this operating system main core is called kernel, and kernel does a set of activities by storing those activities in kernel space and user space. So operating system, depending on the type of kernel and kernel services, purpose, and type of computing systems where OS is deployed and responsiveness to the applications. OS is classified into two types: general purpose OS, real-time OS. General purpose OS means an operating system which is deployed in general computing systems such as desktop systems. They require that the kernel is more generalized and it does all the required services. It is not deterministic in its behavior. It can have some delays in its behavior. And your personal desktop system is an example for general purpose OS. Windows XP, MS-DOS, they are examples for general purpose OS. And OS deployed in embedded systems demand real-time response, so which requires deterministics. And in order to implement this scheduling policies which execute high priority tasks, we prefer real-time OS. So those implementing time critical allocation of system resources are example of real-time OS requirements. Windows CE, QNX, VxWorks, Micro C by OS2 are examples of real-time OS. So there is a general purpose OS. The general purpose OS is nothing but Windows XP and MS-DOS, and the real-time OS is Windows CE, QNX, VxWorks, Micro C / OS2. These are examples of real-time OS. What is real-time OS? The real-time OS is also having a kernel which is doing some set of services, specialized and this they have minimal set of services, and the basic function of this real-time kernel are task process management, task process scheduling, task process synchronization, error exception handling, memory management, interrupt handling, and time management. So first we'll see what is real-time task process management. If there are multiple tasks occurring, so assigning priority to the task, scheduling the task is done by this real-time kernel, and synchronizing the multiple tasks. If error is occurring, um, going for exception handling and memory management. So whichever task is completed, you have to empty the memory and allocate memory dynamically. And if any interrupt is occurring, that interrupt must be handled, and the time allocated to the each of the services must be monitored. So in this topic, we have studied that we are having an embedded system based approach for our programming languages, and where we are using an operating system in order to control the hardware and the application software and allocating the resources. And in such a case, we can use two types of OS. One is general purpose OS, another is real-time purpose OS. So we'll cover our and other topics in coming classes.